Okay, since we are done with the transportation demand models, let's proceed to the traffic impact assessment. So, first, what is traffic impact assessment or your TIA? So, a traffic impact study or a traffic impact assessment is a study which assesses the effect that a particular development has on the transportation network. A traffic impact study is generally required by roads authorities to evaluate the impact of a change in land use. So, your traffic impact assessment will answer the questions of what will the effect of a development to the surrounding transport facilities? Second, what is the magnitude additional traffic due to the development to the existing traffic? Third, how will the additional traffic affect the current traffic? And lastly, what is the proposal to alleviate or minimize the impact? So here are the activities of a transportation impact assessment. So first we have the developer going down to the architect or the town planner, then the local authorities moving next to the instruction by the local authority to execute the TIA. After doing that, they will create an appointment to a transport engineer, then discuss um, the scope of the study and the study methodology. Then collate existing data and information. Then that's the time you are going to start the traffic study. So the analysis for that would be again your your transportation demand models. You have the trip generation, modal split, trip distribution, your trip assignments. You also have there the analysis of the LOS or your level of service, which is rated from A to F, which is A being the highest and F being the lowest. Then we have the problem evaluation, the proposal to alleviate or reduce the identified problems. So that will all be inside your analysis. Then you're going to do the review the original layout plan and propose an improvement to the client and the land use. So the final output for this would be your final report or your TIA report. So when is a TIA required? So any development needs to have adequate infrastructure to support it, whether utilities or transportation. As a result, every proposed development requires an assessment of the adequacy of the site. For example, compatibility with highway and municipal plans, access locations, geometry, capacity, traffic control, etc., and any necessary improvements to safely accommodate to proposed development. Similar with your infrastructure, we do environmental impact assessment. So in this case, transportation impact assessment. So focusing on transportation. So there are two levels of assessment. So in general, um, there are two levels of assessment that may be required in support of a development. So we have our first, we call the comprehensive report, which is used for larger development with significant traffic impacts or at complex location where the recommended improvements require a detailed analysis, while the other one is the memo report. So this one is used for small development with low traffic impacts at simple location where the recommended improvements can be assessed in a memo format. So typically, a subdivision, pre-developed plan, or development that potentially generates high traffic volume requires a comprehensive traffic impact assessment. While this includes but not limited to area structure plans, neighborhood structure plans, change of zoning, a resulting increase of traffic, increase in density from previous TIA, special land use scenarios, etc. If the anticipated traffic impact is low, for example, ITE trip rate is used, standard intersection treatment, no oversized vehicle, no capacity issue, traffic signal not warranted, intersection site distance is adequate, no other operational issue, then a memo report may be sufficient. While the following sections of guidelines provide general requirements for a comprehensive assessment, the level of analysis required in support of each development proposal may vary depending on the complexity of the site. Certain sections may not be applicable, while other additional analysis may be required. Moving on, what is the content of this traffic impact assessment? So, a report format of this one, based on the TIA guidelines of Alberta Transportation Traffic Impact Assessment Guidelines. So, first, we have the recommended TIA report format. We should have the executive summary. Number two, introduction and proposed development information. Three, future highway and municipal plans. Four, existing infrastructure conditions. Five, background traffic and projection. Six, development traffic. Seven, post development traffic. Eight, intersection treatment warrants. Your analysis, conclusions and recommendations, including the proposed intersection plans, and lastly, the appendices, or where your scopes and supporting documents, calculations, correspondence, etc. are found. Let's start with the executive summary. The Transportation Impact Assessment preparer shall include an executive summary at the beginning of the TIA report to provide a short synopsis of the key findings, conclusions, and recommendations. At a minimum, it shall contain the following information. It should have the location of the study site with respect to the area roadway network. It should also have the description of the proposed development that includes the type, size, land uses, construction phasing, proposed accesses. The third one, it should also discuss the municipal findings of the analysis, including existing traffic conditions, programmed transportation improvements, amount of site generated traffic, and the projected traffic volumes. Also, in the executive summary, it should have a summary of study conclusions, including future levels of service, or your LOS, with and without proposed development. And lastly, it should contain the identification of all mitigation measures recommended, including a discussion of when to implement the improvements to achieve the best LOS on highway network. The introduction of background information is to provide an understanding the proposed development and its location with respect to the provincial highway system. So this portion of the report should provide the following information: a history related to the transportation analysis, including the applicant, landowner, type of application the analysis is supporting, site history, including previous applications and analysis, etc. It should also include an overview of the scope of study, including study rationale, study goals, scope, and methodology. See the proposed development. It should have an on-site development. It should have the name, location with legal land description of the proposed development, land use, intensity, and size of the development, access locations, staging plan, expected dates of completion and full occupancy of the ultimate development of any interim phases, and the previous site history, including previous applications of TIA's recommendations, etc. Still, it should have in the study area, it should contain influence area, typically within 1 kilometer from the first highway access, area of significant traffic impact, and the adjacent land uses and other developments nearby. TIA should include traffic by other proposed developments. So as a part of the background traffic, it is best practice to have a combined TIA for multiple developments within the study area to see the cumulative effects it will have on the highway. So the next part would be the existing roadway network. So number one, it should have the highway number, control section, and the kilometer. Highway service classification, whether it be national highway, municipal highway, barangay road. Roadside management classification, functional classification. We have that farm to market road, etc. It should also have the e-maps and plans. What is that? It is your site location plan and your site plan. Next will be the access management, highway, and municipal plans. So the TIA consultant should identify the nature and timing of any planned transportation system, improvements in the approved regional, provincial, and area municipal capital programs that are within the study area and may affect transportation to or from the proposed development. This should include any upgrades to the road infrastructure that is expected to occur, as well as any changes to the roadway network and any future infrastructure. The TIA consultant should consult with and refer to any applicable municipal development plans, municipal transportation master plans, area structure plans, highway planning studies, access management strategies, other approved TIAs in the area, etc. The TIA report should provide the reviewer a full understanding of the study area. It should discuss whether the proposed development is compatible with such municipal and highway plans and recognize the potential conflicts, impacts, and opportunities for incorporating improvements to address the impacts as required. So, the purpose of this section in the report is to present the existing roadway system in the area servicing the proposed development. So the report should provide a description of the existing transportation system and its condition within the study area, emphasizing the major travel routes to and from the site. It is recommended that a site visit or inspection be conducted as part of our TIA. So the following is a list of information to be included in ATA, starting with the existing highway and road network conditions. First, it should have the existing lane configuration, design and posted speed limit of the highway and intersecting roadway. Third, the locations of speed limit changes. Pavement width, so the lane, the shoulder, and the median width, and lane markings. Number five, the right of way width, horizontal and vertical alignment of highway, the vertical grades of the highway, the sight distance, the longitudinal barrier and end treatments, the hazards in the clear zone, existing illumination in vicinity, include type of illumination if applicable, and traffic control type. So for example, two-way or all-way stop control, traffic signals, etc. Number 13, it should also have a traffic operation signages, for example, no left turns, no parking, etc. Existing and planned accesses in the vicinity, that is, driveways, frontage roads, private roads. 15, any other modes of transportation, for example, railway, pedestrians crossing, trail, bicycle lanes, transit routes, and stops. And lastly, any existing operational issues and apparent collision issues in the existing highway and road network conditions. Moving on to the next part in the existing infrastructure conditions, we should also know the existing intersection conditions. So first, intersection treatment type and configuration. It should be detailed, either a plan or a description with radii, taper lengths or and rates, storage lane lengths, etc. Number two, horizontal and vertical alignment of the local road. 3. Vertical grades of local or intersecting road. 4. Assess spacing from adjacent access locations. 5. Intersection sight distance for all designed vehicles. Stopping sight distance for all designed vehicles. Signal timings if applicable, and other developments using the intersection. So in the DPWH, we call this ROCON, so road conditions. So this section, the traffic conditions determines the background traffic volumes that will be used in the analysis of the proposed development. The report should contain information on existing 24-hour traffic volumes and should also provide the existing peak hour turning movement volumes for the major intersections in the study area. The peak hour shall be determined as any time frame that will have the greatest impact to the highway system and that will generate the highest volume of traffic to or from the development on a typical day. Time frame may vary depending on the type of development, but typically should be morning peak from 6 a.m. to 9 a.m. And in the afternoon, peak would be 3 p.m. to 6 p.m. Weekend peak from 11 a.m. to 2 p.m. If peak hour in the study area is known to occur at a different time of day or the proposed development have unusual peaking characteristics, other peak periods should be specified in addition to typical peak hours so that the worst traffic scenario can be captured. For example, restaurants peak hour happen around mealtime, school peak hour at morning drop off and afternoon departure times, something like that. So the highest traffic volumes for a given maneuver at a major intersection may be higher during a period that is not peak hour for the development. In this case, volumes not identified as the peak hours for development generated traffic would dictate storage lengths or lane needs. The TIA shall still provide an evaluation of the traffic volumes for the intersection's peak hours to ensure the improvements are appropriate to handle the system's traffic. Improvements that meet the highest traffic volume needs should be proposed. So first we have the existing background traffic. So the TIA consultant should use the traffic data sources above as the primary basis of existing traffic volumes and shall only conduct new traffic counts when valid traffic data does not already exist. The TIA shall document the data sources and independent data collection methods. The manual traffic count must be a minimum 12-hour count as indicated in a highway geometric design guide in section A4.4 on a typical day broken into 15-minute intervals in order to capture sufficient traffic data to determine the AM peak, PM peak, and the noon peak. So the counts include the AADT at points on the highway and on highway links raw turning movement count data and hourly volumes on highway points. The TIA consultant should use the traffic data sources above as the primary basis of existing traffic volumes and shall only conduct new traffic counts when valid traffic data does not already exist, as what I have said a while ago. So the AADT, or your annual average daily traffic, that's their AADT, while your ATR is your automated traffic recorders. So from existing background traffic, for traffic signal warrant analysis, the raw manual traffic count must be factored to represent the typical day volume before entering into the signal warrant worksheet. Factoring method is listed below. So you have this one. So the factor is equivalent to AADT in the count year over ATR, which is 24-hour daily volume on count day. So the factor count for current year horizon is equivalent to raw traffic count times the factor times 1 plus growth rate percent times number of years. That's for scenario 1, when the traffic count was collected on a day in the past. While for scenario 2, the traffic count is collected in the current year where your ATR 24-hour count and your AADT for the current year are not available. So you get to have this equation. So when pedestrian demand is present at the studied intersection or where pedestrian traffic accommodation is anticipated, pedestrian counts should also be collected. So you have to do that. So number 2 would be the projected background traffic. So it calculates traffic growth rate as a non-compounded average annual growth rate expressed as a percentage of the current or most recent traffic volume count. Consultants should estimate traffic growth rate either by two-point method or linear regression method from the historical traffic count data available. The consultant should make the choice of method with the goal of selecting a reasonable growth rate that has a low probability of underestimating future traffic volumes. As traffic growth rate is dynamic, different growth rates may be used for different development horizons in order to simulate the traffic growth trend. However, justification must be provided. Although traffic growth rate varies for every section of highway, the average annual non-compounded growth rate on the provincial highway network is about 1.5 to 2% from year to year if there are not sufficient traffic count data to determine the traffic growth rate or historical traffic indicates negative or low growth for the purpose of the TIA. An average annual non-compounded growth rate of 2% should be used as a lower limit for provincial highways. So the traffic projections must be prepared for the build year or such other years as may be appropriate due to development staging. The background traffic should be projected to the minimum 20-year horizon, so 20 years. So here in the equation, TV future is equal to TV existing or your traffic volume times 1 plus n times the percentage over 100 quantity. So the number of years will be your n. So for traffic generated by other developments, so traffic projections generated by other nearby proposed or planned developments should be taken into account. The proponent should contact the municipality for future land use information. When multiple developers are advancing development proposals that affect the same study area, a joint TIA should be coordinated to review cumulative impact. To determine the impact of the proposed development, it is necessary to estimate the trip generation of the development and identify how to distribute the generated traffic to the area roadway network. So there are four steps transportation model that should be followed. Again, it is the trip generation, trip distribution, mode split or your modal split, and the traffic assignment. So the TIA consultant must estimate the trip generation, distribution, mode split, and assignment associated with the proposed developments for the commencement day, full build-out year, and each horizon year included in the analysis. Rationale for the selection of design or facing horizons should be provided. For complex projects, a longer projection horizon may be required. For each projection year, a table and or turning movement diagram should be included illustrating the estimated development traffic by turning movement. So here is a sample table for ITE, or Institute of Transportation Engineers. So the trip generation manual. So the ITE trip generation handbook provides detailed explanations of the data, cautions in its use, and a methodology for collecting additional data. So we have here AM peak, PM peak, AM peak, PM peak. So the TIA should present the trip generation information in an organized manner. Information such as land use and size, ITE code, daily and peak hour trip rates, number of vehicle trips generated should be identified and presented in tabulated form as suggested in this table. So here are the analysis. First, we have the intersection treatment warrants. So here, the intersection treatment warrant system has been prepared to assist designers in choosing the appropriate intersection treatment based on the main and intersecting road volumes. However, designers still need to carefully review each proposed intersection to ensure all potential problems are addressed. So the second analysis would be the capacity analysis. So the TIA consultant shall conduct analysis of traffic volumes, facility capacity, and level of service for each intersection in the immediate area of the development within the study area. Capacity analysis must be undertaken for all traffic scenarios as appropriate, such as signalized and unsignalized intersection roundabouts, weaving, merging, diverging, queuing analysis, intersection traffic controls, etc., as per the Transportation Research Board's Highways Capacity Manual. Next will be the traffic control needs. So the TIA should identify, discuss, and describe the need for the recommended traffic control treatments as they relate to the proposed development. This includes identifying the appropriate type and location of the required traffic control. For example, stop control, traffic signal control. And this is to recommend intersection or interchange type. For example, roundabout, diamond interchange, other alternative treatment types, etc. So that's the traffic control needs. Number four will be the traffic safety. So safety of all road users, including vulnerable road users where applicable, must be taken into consideration during the preparation of the TIA. The report should identify and make recommendations regarding any geometric and operational issues that may impact safety, as well as any apparent collision issues. When there is significant concern over the development's effect on road safety, a more detailed traffic safety analysis is given, such as a standalone in service review may be required. So that's for the traffic safety. Next would be the illumination warrant analysis. So here, lighting warrants for rural and semi-urban intersections must be determined based on the tax or the illumination of isolated rural intersections and guide for the design of roadway lighting. So lighting warrants does not indicate an absolute requirement but rather a trigger for consideration. Recommend illumination type should be stated in the report. In some cases, illumination may exist a couple of intersections over. If illumination is required at the studied intersection, infill lighting would be required between illuminated intersections. So that one's for lighting. And then number six, it would be the pedestrian warrant analysis. So pedestrian movement accommodation is an important issue, especially in the urban and semi-urban areas. So depending on the type of development and its interaction with the surrounding community, pedestrian movements can become a significant issue. Consequently, improvements to pedestrian facilities may be required. On the other hand, at isolated rural developments, pedestrian movements are not likely an issue. If applicable, the TIA consultant should conduct pedestrian warrant analysis. Next, we have is the design vehicle accommodation. So an assessment of design vehicle requirements is a critical phase of the TIA and must not be overlooked. As part of the intersection improvement analysis, it is necessary to ensure that the design vehicle is capable of safely maneuvering the intersection without interfering with other traffic movements. Larger design vehicles on high load corridor, long combination vehicle routes, and log haul truck need to be considered at the proposed intersection if applicable. And lastly, we will have the access management and rights of way. So for a TIA report must be address improvements to the highway involving removal, relocation, or alternation of existing accesses to maintain minimum spacing and ensure highway safety under post-development condition. If the location of the existing or proposed intersection is a concern, for example, insufficient intersection site distances, intersection on grade or curve, insufficient access spacing, proximity to adjacent intersections and accesses, etc., the TIA consultant should evaluate access or corridor operations analysis. For example, weaving analysis, and provide options such as alternate access, consolidation, or relocation of the proposed access. So these are the analysis. There are eight that you have to consider if you are going to be using the TIA. So for the conclusion and recommendation, the TIA should summarize the findings of the various analyses conducted, including potential issues, and clearly outline the recommendations regarding first, required geometric improvements, signalization, roundabout, or other controlled types, operational and safety issues, pedestrian mitigation, illumination, right of way requirements, and your access management. Although the TIA is typically conceptual design, it often leads to detailed design, which relies on the TIA analysis. As a result, the TIA recommendation should have sufficient detail of what the conceptual intersection configuration will look like. For example, turning bay lengths. A concept plan illustrating the recommended horizontal intersection layout should be provided. So here is the TIA summary chart. So you can see there the date, the consultant, the project. You also have there the site information. What is that? The development type, highway number, legal land description, posted speed, so on and so forth. Then you also have there the warrants, year, left turn lane, right turn lane, signal or roundabout, illuminations, pedestrian. Another box would be the intersection treatment. So you have the intersection treatment type, additional modifications, and the design constraints. So for your additional comments, you have it here. So that is an example of a TIA summary chart. So what are the traffic impact assessment? So you actually have the checklist. First submission would be the concept plan for proposed development. So that includes the land use, staging plan, access locations, etc. On the other basic assumptions and methodologies, that is the trip generation rate, distribution, etc. Your for your traffic surveys, and then your methodology. Then for the second submission, this one there's a lot to be asked that will be asked. So you have the reviewed and signed by professional engineer TIA summary sheet. So the executive summary. So first, you should have the background information. It includes the information related to the study, study scope, goal, methodology, proposed development, under which it has on-site development, the land use, intensity, size, access locations, etc. The study area, area of significant traffic impact, adjacent land uses, and other developments. Letter D, existing roadway network is also is also um, included in the checklist. So you have the highway number, control section, and kilometer, highway service classification, the roadside management classification, and under it is the maps and plans. Again, key map and site plan. Then for the next section would be the future highways and municipal plans. The ATs, highway plans and municipal plans, plan transportation system improvements, confirm compatibility. Next is the access management. So you have the compliance and assess management guidelines. This is under HGDG Chapter 1. Another TIA checklist would be the existing infrastructure conditions, starting with the existing highway conditions, lane configuration, markings, pavement width, horizontal and vertical alignment, grades, speed limits, sight distance, longitudinal barrier and end treatments, hazards, and the clear zone, right of way width, existing and planned accesses in vicinity, existing illumination in vicinity, traffic operation signage, for example, no left turns, etc. Any other modes of transportation, any existing issues, that is, existing highway conditions. The next one would be existing intersection conditions. So under it is the intersection treatment type and configuration, horizontal or vertical alignment of the local road, vertical grades of local or intersection road, a roadway, access spacing from adjacent access locations, intersection site distance for all designed vehicles, traffic control types such as stop signs, signals, etc. Second to the last would be existing signals timings if applicable, and of course the major development currently using intersection. So another part of the checklist is the traffic condition. So In A, you have the existing background traffic, which is the turning movement counts, your AADT, AM, PM peaks, other periods. Again, like vehicle composition in terms of percentage of the vehicle type on highway and its intersections. For B, we have the projected background traffic, your annual traffic growth rate, projected AADT, AM peak, PM peak, other periods. For letter C, we have the traffic generated by other development. So same thing, your AA, your average annual daily trips, AM peak, PM peak, other periods. Your site generated traffic, your site generated trips, trip assignment, vehicle position, and again, composition in terms of percentage of the vehicle type, pass by and or internal trips, and the total trips. In E, we have the combined background plus other plus site traffic. Same thing, and the staging years. Repeat step B to E for 10-year, 20-year horizon or more for each stage. Then on the checklist, it never forget the analysis, under which we have the intersection treatment warrants, including trigger year, capacity analysis, traffic control needs, traffic safety, illumination, pedestrian movements, operational analysis, I just repeated that one, access management and rights of way, and other considerations. And lastly, for your traffic impact assessment checklist, you should have the conclusions and recommendations. So the summarized findings, including issues regarding required intersection improvements, signalization, roundabout or other control type, pedestrian mitigation, illumination, right-of-way requirements, access management. So that's a traffic impact assessment checklist. So let's have the content of a TIA. This is an example from the traffic impact assessment of Riza Atik bin OK Rahmat. I think this one's Malaysian. So the setting is in Malaysia. So the content they have here: the existing situation, the analysis, impact to the road network, road safety, internal layout, parking space, public transport, pedestrian, bicycle, and disabled facilities. So we have here the existing government for number one, the existing government transport policies for the development area, structural plan and local plan prepared by the local authority, and of course the existing traffic and public transportation facilities. So here's the existing traffic flows. We have here a graph by massa and the traffic volume. I think this one's time. Here is one of the intersections. And it has here the traffic volume, green time, lane, capacity, your flow over the capacity ratio. So here, the existing situation, it should have the road safety record, pedestrian facilities, identify all planned transport facilities in the vicinity of the development, identify all other developments in the vicinity of the development, and quantify the combined impact to the external traffic, identify all existing public transport facilities and the impact of the development of the facilities, and identify potential traffic problem in the development. So we have here a table for the generation. You have the first column, the land use. Second column would be the attraction per 100 square meter floor area in the morning, and the production per 100 square meter floor area in the afternoon. So in the office, you have a 3.7 person per hour, while for the production in the afternoon, you have 4.05% per hour. So we have here different land uses. We have the hospital, shopping center, primary school, high school, college, or university. So we have the biggest number of persons per hour is in the primary school. Same thing. So here's the trip generation. So here are the formulas used. Here's the project site, quantity, rates, and the production. So you just multiply this one. You get the production. So they have three destinations. These are the three zones that they had: Ipoh, Batuga, Ja, and Gopeng. So the modal split or the modal choice. So the influence factors, again, you have this: car ownership, household income, distance to the transport facilities, travel time, travel cost, car park availability. I think I have discussed this from the previous topic. Here's an example of the peak hour modal split in Kuala Lumpur. So for buses, they're bus, car or van or jeep, and the motorcycle. So here are the different land use: government offices, company offices, bank, hotel, shopping center, bungalow house, semi D house, link house, condominium apartment, and flat. So we have here buses and cars, motorcycles. There are three modes. So average passenger including driver in Kuala Lumpur. So they have this. For offices, car, van or jeep. Motorcycle, bus bigger, they have 75. Bus mini 35. If you can observe the capacity of these modes. So this one is better, bigger transport. So, a local authority has approved a proposed development of a housing estate. It consists of 1,250 link houses, 155 semi-D houses, 78 bungalow houses, 390 unit condominiums, 820 unit apartments, and 970 units of flats. Calculate both inbound and outbound traffic flows during morning peak hours. So, we have here the modal splits, person trips, and number of vehicles. Households. So this is what it looks like. This is the proposed development. They have three zones. They have an assumption of traffic growth of 4.1% base year of 2010. Traffic generated by the development here. So for the impact of the road network, we already know the level of service or your LOS. We have the flow or capacity or your flow over the capacity, that is your LOS. So if your V over C is less than zero point 0.9, that is okay. So typically there are 6 levels of services so that are defined. Each is assigned a letter designation from A to F, with LOSA representing the best operating conditions and the LOSF is the worst operating conditions. We actually have a table for that. So A as the highest driver comfort, free flowing. So the volume to ratio capacity of less than zero point 0.6, that the level of service would be A. If the volume to capacity ratio is zero point 0.6 to 0.7, the level of service is B, which is a high degree of driver comfort, little delay. While C, acceptable level of driver comfort, you have the volume to capacity ratio of zero point 0.7 to zero point 0.8. D, some driver frustration, moderate delay, that is zero point 0.8 to zero point 0.9. And E, high level of driver frustration, high levels of delay, that is from zero point 0.9 to 1. And if greater than 1, that is the highest level of driver frustration, excessive delays. So that is F. For the content of your TIA, safe to residences and safe to visitors. That is your road safety. Internal layout, parking spaces. In Malaysia, they have 1 CPS per 50 square meter floor area or 1.25 per residential unit. Public transport, your buses, vans, minibuses should be included in your TIA. And then the pedestrian, bicycle, and disabled facilities should also be considered. So that ends my discussion. If you have any questions, you can email me or you can directly message me through our messenger group chat.